Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 308. Please turn to it. Page number 308, and today is our lesson number 25. Very first problem, let's see what we have here. Problem number 19. Problem number 19 is simply asking us which of the following equations that they give us is not linear. Number 19. Which is not linear? Let's find out, shall we? Linear as in equation of a line. Is that how they say it, which one is not linear? Oh, they do not say which one is not linear, but they say which one of the following equations does not represent a line, which is same as saying which of the following equation is not a linear equation, does not represent a line. For example, in answer choice A, they tell us that x equals to 4. X equals to 4, that clearly is an equation of a line. X equals to 4, 1, 2, 3, 4, there's your line. This line has an equation. The equation of this line is x equals to 4, because it doesn't matter what y is. Y can be any value it wants to be. X is always 4. What sort of slope does it have? The slope of this line is infinite. Slope is equal to infinity. So that is a linear. That is correct. That is a linear. Second one says 3y equals 6. If 3y equals 6, then y equals 6 over 3, which is 2. Now what's going to be, of course in the real exam we don't actually have to plot everything out, we're just doing it here for learning purposes. What's going to be the equation, what's going to be the shape of the line for this equation? Let's find out, shall we? Y equals 2, that's all. Y equals 2. So here what this equation tells us is that it doesn't matter what the value of the x is, it doesn't matter what the x coordinate of a given point is. The x coordinate of a given point plays no role at all. Y is always 2. Oh, there we go. 1, 2. Y is always 2. Y equals 2. There you go. And the slope of this line is, of course, a big fat 0. It's a horizontal line. But it is a straight line. It is an equation of a line. It's a straightforward horizontal line. The third one says, let's do it on the top, third one. C says y minus x, x minus y equals 1. Well, that tells us that y equals, if you bring the y to that side and bring 1 to this side, it gives us that y equals x minus 1. Y equals x minus 1. What's going to be the shape of this line? Well, the slope is 1. Slope is 1. And the y-intercept is negative 1. Y-intercept is negative 1. And the slope is positive 1. So it goes somewhere like this. Oh no, that's a negatively sloped line, sorry. It goes something like this. It's a positively sloped line with a slope of 1. That's all. But it is an equation of a line. Last one, y is equal to 3 quarter x minus 2. That is also a linear equation. The slope is 3 quarter, the y-intercept is negative 2. Y-intercept is negative 2, 1, 2, negative 2. And the slope again is positive, so it goes somewhere there. There we go. With a slope of 3 quarter. Let's look at E. I don't know how I managed to make such a big fuss out of this one. This is a very straightforward problem. There you go. X squared. There you go. That's it. As soon as we see x squared, this equation is of second degree. This is how we speak. This equation is of second degree. It's x squared. This is not linear. This equation is not linear. This is a quadratic equation. This is a quadratic equation. The equation of the shape of this line, if you were to plot it, it's not going to be a straight line. Shape of this graph is not going to be a straight line. You understand? It's not linear. Number 20. Number 20. In number 20, they're simply asking us which is true. Which is true. And the triangle that we have is this. A, B, C is a right angle triangle and it's a 5, 12, 13 triangle. 5, 12, 13 triangle. We just have to go through one by one and see whether or not they are true. The first one says cosine equals cosine of A. Cosine of A, well, cosine is going to be A. Remember A right here. Adjacent, which is 5, over hypotenuse, which is 13. 5 over 13. But they tell us, they give us 12 over 13. That of course is not true. It is 5 over 13. It's not 12 over 13. The cosine of A is going to be adjacent, which is 5 over hypotenuse. Answer choice G says sine of A equals, well, what is sine? Sine is opposite over hypotenuse. Opposite to this angle is 12. Opposite to this one is 12 over hypotenuse, which is 13. And what do they give us? So they give us 12 over 13. There you go. The answer is G. G is the correct one because it says which one of the following is true. And obviously we're not going to find two answer choices which are going to be true. We found the one that is true. Just to satisfy our curiosity, let's make sure that the other three are wrong, okay? H says tangent of A. Tangent is going to be opposite, which is 12 over TOER. Remember, SOCA TOER. SOCA TOER. Opposite over adjacent. Why? I just made a mistake. Oh, it is right. Opposite, right here, 12 over adjacent, which is going to be 5. And they give us 12, it's 12 over 5, they give us 12 over 13. They give us 12 over 13, which is wrong. J, answer choice J, they tell us cosine of A. And cosine of A, we just found it. Cosine of A is 5 over 13. Cosine of A is 5 over 13, they give us 13 over 12. They give us the same answer as before, except the reciprocal of it. Before they gave us 12 over 13, now it's 13 over 12, it's not going to change it. The correct answer is 5 over 13, this is wrong. And in K, sine of A, well, sine of A, whatever they give us, obviously, we already found out sine of A is 12 over 13. It's not 13 over 12. It's not 13 over 12. This is wrong. So in K they give us the reciprocal. In answer choice K, they give us the reciprocal of the correct answer. They give us the reciprocal of the correct answer to catch those people who are not attentive, who are not paying attention. You must concentrate, you understand? Otherwise you're going to end up making some silly mistakes. You must pay attention. Sine is opposite over hypotenuse, not the other way around. That was it, number 20. Let's move on to number 21. In number 21, what is the slope of a line that is parallel to this line? Okay, slope of a line parallel to 7x plus 9y equals 6. Well, if they are parallel, if the lines are parallel, of course they have equal slope. So if you can figure out the slope of this line, the slope of the line that is parallel to it, it's going to be the same slope. These two lines, if they are parallel, they have the same slope. So let's find out the slope of this line. In order to figure out the slope of this line, we need to write it in the slope-intercept form. We need to write it in this form, y equals to mx plus b, and m is your slope. So we need to put it in this form. In other words, we need to solve this equation for y. Let's put it here, 7x plus 9. 7x plus 9y equals 6. And we just have to solve for y, that's all it is. Is that right? Is that the right equation? 7x plus 9, there you go. Subtract 7x from both sides, so we get 9y equals to negative 7x plus 6. And then divide both sides by 7, divide both sides by 9. Divide this side by 9 and divide that side by 9. So y equals negative 7 over 9, x plus 6 over 9. Voila, this is your slope. The slope of the line that is parallel to this line is going to be the same slope, which is negative 7 over 9. Negative 7/9 is the answer, whatever that answer choice is. Negative 7/9 is answer choice B. Answer choice B. Let's move on then. Number 22. number 22. In number 22, they're telling us that the braking distance y for somebody's car is given by the following equation here. Y equals to, this is number 22, 3 times x squared plus 10x over 40, where y is the braking distance, y is the braking distance, and x represents the speed of the car. X represents the speed of the car. What's the question asking? According to this model, which of the following is the maximum speed? We're looking for the maximum speed in miles per hour that he can be driving so that the braking distance is less than 150 feet. We want the braking distance to be no more than 150 feet. The question is, if that's what I want, if I want the braking distance to be less than or equal to 150 feet, then what's the fastest that I can drive? What's the fastest speed that I can drive the car at? You understand? Let's find out, shall we? So our braking distance, the question here is, what's the maximum speed at which the braking distance is less than or equal to 150 feet. And how do I find our maximum speed at if the braking distance has to be 150 feet or less? Well, here's our model. The model tells us that the braking distance that we want, which is given by this model here, 3 times x squared plus 10x over 4, this is the quantity. This is the quantity. I do not want this model here gives us the braking distance. Once we substitute the value for the speed, whatever the speed is. For example, let me give you a simple example, very simple one. For example, if you're going at 1 mile per hour, then it's going to be 1 squared, which is 1, 10 plus 1 is 10 plus 1 is 10 plus 1 is 10 times 1 is 10, 10 plus 1 is 11, 11 times 3 is 33. When x is equal to 1, we get 33 over 40. What does it tell you? 33 over 40 is less than 1. What it tells you is that if you're driving at such a low speed at 1 mile per hour, you could be almost touching the guy's fender. The distance between you and the guy in front of you could be as less as 1 foot, and you'll be fine. You will have enough time to react. You will have enough time to react when he puts his foot on the brake, and when you see his brake lights go on, you will put your foot on the brake and you will have enough time to react because you're going so slowly. The question is, what's the maximum speed that I can go so that this quantity is less than or equal to 150 feet. That's what we're looking for. That's all it is. Let's do it on the top. Actually, we can do it right here. Divide both sides by 3. I see 150 here and I see a 3 here. 150 is evenly divisible by 3. They have a factor of 3 common. First thing that I'm going to do is divide both sides by 3. Divide this side by 3 and divide this side by 3. And of course this 3 will cancel out and 150 will become 50. Now what I'm going to do at this point, is I'm going to not show you the baby step. I'm not going to show you the baby step. This was a baby step. We don't need to show that. We are grown up. We are grown up people. You can just divide both sides by 3. And if you divide both sides by 3, this 3 disappears and this 150 turns into 50. Are you with me so far? Let's continue. Now let's multiply both sides by 40. Multiply both sides by 40. If you multiply both sides by 40, this 40 will cancel out with that 40. And what are we left with? We are left with x squared plus 10x. X squared plus 10x has to be less than or equal to 40 times 50. 50 times 40 or 40 times 50. Okay, we're almost done. I should have started from the top. I should have done it on the top, but since we are... Now, here's the tricky part. I see x squared here, I see 10x squared. Don't convert this into a quadratic equation. It will be a pure hell. Do you understand? Keep it simple. I see x squared here and I see 10x here. Do you find any common factor between x squared and 10x? The common factor between these two terms, these are called terms. This is one term and 10x is the second term. The common factor between these two terms is x. Let's take out x common. If we take out x common, from here, from the first term we are left with, let's line them up so we can see them properly. Once we take out the x common, from the first term we are left with x. And once we have taken out the x common, from the second term we are left with 10. There you go, you see, because x times x is going to give us our x squared, and x times 10x, x times 10 is going to give us our 10x. So what we find is x times x plus 10 has to be less than or equal to 40 times 50. We're almost done. Can you tell me now, can you recognize what x must be? Well, this is x, this is some quantity x, and this second quantity here is 10 more than that. Let's do it on the top now. Let's do it on the top. I'm going to erase all of this thing. Let's do it on the top. What we have here is x times x plus 10 has to be less than or equal to 40 times 50. What do you notice? Here we have some quantity x, and here we have some other quantity. Here we have some other quantity, which is 10 more than this quantity. Are you getting? Are you picking up on it? This quantity times some other quantity, which is 10 more than that. What do you suppose that quantity must be? Oh, what the hell? That quantity must be 40. Here is, see, I see it here, 40, and then another quantity, which is 10 more than this quantity. So this is your x, which is 40, and here is our 40 plus 10, which is our 50. That's it, which means x has to be less than 40, less than or equal to 40. The speed at which you can drive the car has to be less than or equal to 40. You cannot, in other words, you cannot drive anything more than 40 miles per hour if you want to make sure that the braking distance is at least 150 feet. Do you understand? That's it. We're done. I will see you tomorrow, or we'll continue with the next page, page number 309. And now we're getting into the second half of the exam. As I always remind you, there are 60 questions there. Out of the 60 questions, the first 20 are a piece of cake. They are very simple, they are very straightforward, they are easy. The next 20, when we get into it, they begin into the medium territory. And of course, by the time we get to the last 20, then they get a little bit more challenging. We are in the second half of the exam, so now we have to be a little bit more careful because they're going to become, they will begin to become a little bit more challenging. Do you understand? I'll see you tomorrow, okay? Bye now.